Welcome to another episode of Data Science. Here we are going to take another data set and then we are going to perform certain operations on that data set and we are going to see some certain aspects of the data set. We are going to see the distribution of the data set. We are going to observe whether the data set is normally distributed or not, and if the columns or if the variables of the data are not normally distributed, then how can we apply any transformation to the data so that it is being converted into normal distribution. So basically, suppose I have a data set and I want to check that whether the variables of the data set are normally distributed or not, then what kind of operation we can actually apply to it, or what is the code to apply that. Similarly, if I want to convert that variable into a normal distribution, then there are multiple methods to do it. One of the very famous method is Box-cox transformation. Another very famous method which is very much applicable also is Johnson method. So how to apply those methods and what are the codes for that we are going to observe today. So at first, all of the packages that are required, NumPy packages, Pandas packages, Cbond packages, matplotlib.pyplot packages, Skype.stats packages, and sklearn.model selection. From sklearn.model selection library I have imported 10 test split. From sklearn.model selection I have imported cross-vals code, which is nothing but cross validations code, which is going to give us the modification of the model. So if our r square is not a, suppose our r square is very high, then with the help of cross-vals code we can check whether um, the r square is supposed to be that much high or not. Suppose the r square is 0.90. So that means 90% of the variation of the independent of the dependent variable can be explained by independent variables. So that is a very big interpretation, right? But if we want to check that really if our dependent variable is being explained by independent variable by 90% or not. So for that we will apply cross-vals code. Cross-val score, if the cross-val score is also coming very high, then we can obviously say that the independent variable is actually expelling the dependent variable very well. Now if we see, we are going to explain that also. Now from sklearn.linear model, I have imported linear regression. From sklearn.metrics, I have imported R2 score. And from sklearn.preprocessing, I have imported power transformer. Power transformer is nothing but it is a package of the sklearn.preprocessing library, which is basically the library is sklearn, and from the sklearn library we are importing these packages, and this power transfer will actually help me to apply the Box-cox transformation and the Johnson method or Johnson transformation. So at first I have actually imported the dataset, which is the concrete dataset, which is freely available on the internet. You may check out for it. Then I have, for observing the first 5 rows and all the columns of the dataset or all the variables of the dataset, we may apply df.head. df is nothing but the variable in which the dataset is stored. So we have actually passed our dataset concrete into the variable called df. Now, if we want to see the first 5 rows and all the columns or all the variables, then we will apply df.head. Then so as you can see, cement, slag, ash, water, superplastic, coarse egg, fine egg, age, strength. All of these are basically the variables in the dataset. Now, if I want to see that how many rows and how many columns are there in the dataset, then we may apply df.shape. It is actually telling us that there are total 9 columns and 1030 rows in the dataset. If I want to check is there if there is any null value present in the dataset or not. What is a null value? Null value is basically a missing value. Suppose the first observation of the age column is 28. If NA was present here, then that means it is a not available. The value is not available. It is not given. It is a null value. So if I want to check whether there is any null value present in the dataset or not, for that we may apply df dot is null bracket opened and closed dot sum bracket opened and closed. As you can see, all the variables is present and there is no null value present in the any of the variables. So that's why all of these are showing 0. If I want to see the maximum value, minimum value, standard deviation, mean, maximum value, minimum value, 25 percentile, 50 percentile, 75 percentile value, then we may apply df.describe. Now, I want to suppose I want to run a regression, and which variables are basically going to be our independent variables? Our independent variables will be all the variables except a strength variable. We are leaving this variable because this variable is nothing but our dependent variable. And so that's why we are dropping the column string, and all of the other variables are being stored in the variable called x. So this is basically nothing but our independent variables. X is representing our independent variables, y is representing our dependent variable, and in y we are just storing the column called string. Okay. As you can see from the data set, here we are giving -1. What does it mean? I log -1 means the last column will be stored. The last column will be stored in the or the last variable will be stored in the y, and which will be representing our dependent variable. Now it is going to give me four set of values: x chain, x test, y chain, y test. For that we will apply chain test split command, and we are going to give x and y in the chain test split. We are going to assign test size, which is 0.2. It means that 20% of the observations will be in the test set and 80% observation will be in the training set. And random set equals to 42. It is nothing but it is a um, it is found in the sklearn library. We have to assign a random state. There are some other random states which are also available. Now we are assigning linear regression as LR, and we are fitting the X chain and Y chain, and then we are going to predict the Y with the help of X test, and then we have a predicted value of Y which is stored in Y pred, and we have a actual value of Y which is stored in Y test. So we are going to predict our R square with the help of actual values of Y which is Y test, and predicted values of Y which is Y pred. And with the help of Y test and Y pred, we are going to find the R2 score, or that means the R square basically. So R square is showing 0.60, which is almost 60%. That means 60% variation of the dependent variable can be explained by independent variable. Now if we want to check that whether really that amount of variation of dependent variable is being explained by independent variable or not, then for cross checking it we may use cross val code. So for applying cross val code, what is the code? Np.mean cross val code, you have to give LR, which is nothing but the linear regression. You have to give the value of x and y, and then you have to give scoring equals to R2. The cross val score is actually also coming out to be 0.60. That means really the 60% variation of dependent variable can be explained by independent variables. Now if we want to check the distribution plots of the all the columns of the data set, for that we will actually apply the displot sns.displot, and we are going to apply xtrain column, and then we are going to find the probability plot. So that is stats.probability plot xtrain columns, and here our distribution equals to norm means normal, and plot equals to plt. So as you can see, if we see the distribution, as you can see, the distributions are not looking normal. This is core set kind of looking like normal, but some of these are looking like normal but look like look at age. These variables are not looking normal or normally distributed. Superplastic is not even close to be normal. So if you want to convert this into a normal distribution, for that we will apply Box-cox transformation. So I will just apply power transformer method equals to Box-cox, and I will store it into a variable pt, and I will just pass it to extend transform, and I will just apply it pt dot fit transform. Here pt is denoting nothing but the power transform. So here on the extend, the values of extend the power transformer method Box-cox will be applied, and xtest transformed we will also apply on that. So if you want to see the lambdas of Box-cox, then these are the values of lambdas of Box-cox. And now after applying Box-cox, if we again run the cross-valve code, then you can see that the R square or the cross-valve code has improved a lot. And now if we want to see the dist plot or distribution plot, so whether it is showing normal distribution or not, as you can see, it is much more now looking like a normal distribution, and it is converted to be a normal distribution.